Hey everybody, how's it going? Today I'm gonna fix a MacBook. Here we have a MacBook that's not turning on and not charging, that my assistant did not open because they fucked up the bottom screw so bad that he could not get it out of the machine. So we're gonna see if I can get this bottom screw out, and no, it does not want to come out. So I'm gonna share a little trick with all of you. So what we do here, see this? These are fine-tipped snippers. This is an Exolite 175M. And what you can do with an Exolite 175M is you can grab the screw and get under the screw, which is what I'm going to try to do here because this screw is fucked. I'm just going to cover the customer's name so you can't see that. Nobody tries to call them, stalk them, do any weird shit. And we're going to get the overhead camera on over here, and we're going to see if I can get rid of this freaking screw because this thing is stuck. All right, so see this? So we take the Exolite 175M fine tip snipper, drill in. Yes! And we turn. A lot of people try to do stuff with Dremel. I think that the amount of damage you're probably going to do when you're dremeling, trying to avoid damage to the case, you're going to wind up doing way more damage than you do with this. It's also cheaper and way better. Have you been sleeping well enough? I have been sleeping. I'm not feeling well for a number of things. Honestly, it's just not something I feel particularly excited to discuss on camera at this point in time. But no, a lot of people think that I don't sleep. I slept very well. I've been sleeping very well over the past few weeks. It's just something else altogether. So I am going to go over this, and we're going to try and figure out what's going on with this MacBook. So I'm going to turn on my power supply. Let me get my power supply software on. Let me get the multimeter software on the screen, all that good stuff so that you can see how much power this MacBook is actually using. So I'm going to turn this on. And come on, start. There we go. All right. And let's see, what do we have here? So I'm going to multimeter, toggle on or off. Okay, it looks like we're taking 6 milliamps, which is pretty useless, as most of you might imagine. So this is an A1502. This has an A204924 board inside of it, and we're going to try and figure out why it is that this is not turning on. So I'm going to get my magnet, which was right over here. Just actually taped to the bottom of the computer. Doesn't make any sense that it was in a bag on the bottom. Strange, but we are going to get this board out of the case. We're going to see if we can figure out what's wrong with it. Honolulu's rail project price tag hits $12.4 billion. Don't talk to Erica about the rail. When you talk to Erica about the rail, it fucks her up inside. Like that's one of those things that just, I mean, if you want to convert a Hawaiian to a libertarian, just talk to them about the rail. So yeah, every time I talk about the rail with Erica, her face kind of... I try to avoid talking about the rail with Erica because she's going to look like she's 50 in just, in a month or two. If her face gets stuck with all those wrinkles and grimaces in it. Like when I tell Erica about the rail, you could see she's like... And I know that that's not going to be good for your face because it's eventually going to get stuck like that. Did you get the straw in your case, pee-pee bus? Honestly, people here, they have zero desire or inclination to do videos. And that's quite obvious. Like, people will do it, but there'll be some huff, some puff, some and it's just like, you ever hear Bill Burr with the girlfriend? Where he's like, hey, can you listen, I'm really in pain. Would you be able to take the dog out? Oh, I mean, like, what, why, what, you mean, like, I can, but, like, I have a long day, and this happened, and that happened, and then Bill Burr says something along the lines of, fine, fuck it, I'll do it, and in his skit on why you don't hit a woman. So it's kind of like that, like, it'll be a yes, but it comes with a bit of guilt tripping. So it should arrive 10, top of the hour. All right, now, thank you very much. The people here really appreciate it, Mr. Kelly. Bill Burr is the best. I love Bill Burr. He's a fucking amazing comedian. It's really interesting because I like Joe Rogan's podcast. I genuinely enjoy listening to his podcast. I don't know what it is, but he's really good at getting out of people what other people, or he's good at getting something out of people that you just don't get when they go on other interviews or shows. But I was never a fan of Joe Rogan's comedy. Bill Burr, I think, is a genius legend comedian, but when I listen to his podcast, I don't find it particularly entertaining. But I really do enjoy Bill Burr's comedy. It's like the 2012 skit, the Arnold Schwarzenegger shit, all that stuff. It's fucking amazing. The grocery store. Apparently, I work at a grocery store. Wow. Jeez, must have forgot my apron. Like, oh, it's hysterical. I love Bill Burr. He's good. He's so, like, man. Yeah, you have a bad day, turn on some Bill Burr. It won't be a bad day for long. Okay, so we've taken everything out of the machine. So the first thing I'm going to want to do here is see if after I've taken everything out of the machine, if I still have the same thing when it's only taking 5 or 6 milliamps. And as you can see, it's still pretty much stuck taking 5 to 6 milliamps. So I'm going to open Flex Board View. Hope that the bugs have been fixed in spite of the fact that I never update Paul Daniels software because it would take away my reason to complain to him. And see if anything funny is going on here. So I'm gonna first thing I usually do in these videos is I check for a power rail that's responsible for getting a green light in the charger. I'm just kind of curious if any of you remember what that power rail is. So what power rail is it that gets us a green light in the charger? Can anybody remember? Ever tried DMT? Okay, let's try this again. Which power rail gets us a green light in the charger? You fucks. I ask which rail gets a green light in the charger, and you ask if I've done DMT. Jesus Christ. Okay, let's see. PP3V42 underscore G3 hot. Very good. Yes, it's PP3V42 underscore G3 hot. Yes, that is the rail that gets us a green light. So when we take a look at the schematic and the board view over here, I'm just going to turn this frustrating thing off so you don't see the number up there. You'll see that on this board, PP3V42 is going to power my SMC. And the SMC chip is what communicates with the charger. So this over here is my charge port. See if on the screen you got, this is my charger. That's my charge port. And on my charge port, you're going to have adapter sense line over here. This is my adapter sense line. And this is where the charger here is going to speak to the system management controller here. And System Management Controller requires PP3V42 to work, as does this whole circuit over here that allows the charger to talk. So see, this over here is powered by PP3V42. This chip over here powers this chip over here, and this chip is what allows the charger to speak to it. So we're going to get in checking our PP3V42, and let's see if it's present, let's see if it's not. And if it's not, we got to figure out why. I don't see any obvious liquid damage on this board, but I haven't really looked at it under the microscope. But I'm usually able to spot this stuff without looking in the microscope just from the amount of time I've been doing this. Now let's see. I'm going to just take my multimeter here and I'm going to measure and see what I get. And I get 0 volts on PP3V42, nothing coming into the machine. So the next thing we're going to do, anytime you're missing a power rail, what I like to do is I like to check the beginning and the end of that particular power rail. So I save myself some time. So when I go over to L7095 over here, which is where PP3V42 underscore G3 hot is created, this area, this chip is going to take my 18 volts from the charger or 12.56 volts from the battery over here, and it's going to turn it into 3.42 volts over here. What I want to do is I don't want to check, like, I'm not going to check here and here and here and here. It's a waste of time. What I want to do is I want to check the beginning and the end. And then we so there's a reason that I do this. There's a rhyme and reason to it. And let me just open the PDF in its own screen to make it a little bit easier since we're not using the board view right now. So let's say that my problem is over here, right? Let's say my problem's all the way over here. And I check over here and here and here and here. I'm going to miss the fact that it's over here. So the way I solve it is I check end, here. Then I check here, here. And I keep going like that. It makes life a little bit easier for me. So I'm going to check over here. Let's just get we can check back at the beginning. And to do that, I'm just going to exit the large screen PDF view and go back to the split screen view because I need to see where everything is. So, I want to see what's coming in on R7020, but what is R7020? By the way, Paul Daniels is saying that we should probably try and have a dialogue back and forth with some of the manufacturers, because when I use the word board view and they're opposed to making board views available, they may not understand what I mean. When I say I am looking for a board view file and a schematic, I'm not asking for the thing that I just give to a manufacturer that allows me to completely replicate this immediately. That is a highly complex file with way more information than someone like me could ever need to do this job. What we're asking for is something that looks like this, where when it says R7020 on the schematic, I know where to go on the board. In the olden days, when you wanted to find R7020, you would look on the board, and next to every component, because there was space for it, it would actually say R7020. Everything is miniaturized now, and there's no space to put numbers on the board. So the only way to find where R7020 is in a file like this. And I think part of the right to repair movement is going to have to be clarifying things like this, because for all I know, the people that work there may not actually even know what it is we're asking for. It may really be a game of telephone where they say they're asking for board views, and then that goes to from the PR person or the government relations person to the engineering department person, and then they tell that person they want the board files. And then they say, board files? That would allow them to print out their own board on their own. We can't give them that. And then, it may just be something that's getting lost in translation. So just a little bit of food for thought. Hello from the UK, late night PP bus probing. Well, now it's PP342 probing. John DeComo says, I like what you just did. Throw some right to repair into the repairs itself. It draws people in, and you give some right to repair stuff to fix the overall problem. This is Paul Daniels' thing. So I appreciate that you just gave me credit for Paul Daniels' idea, and I'm not going to in any way protest you giving me credit for Paul Daniels' idea. Although I'll always take credit for Paul Daniels' ideas. Don't get it twisted. So we are going to go back here and check out where R7020 is. So R7020, it says, is right here. And we're going to flip our board over. We're going to have the overhead camera go back on. We're going to put the multimeter on, and I'm going to check and see what I get at R7020 on both pins, on pin 1 and pin 2. So on pin 1 is where we should be getting 18 volts from the charger, and I see nothing. On pin 2 is where it should be coming out. I also get nothing, which does beg the question of whether or not my charging setup is actually working. Well, that's a good one, because I haven't used this desk for board repair in quite a while. So let's go back to the schematic and the board view. Now, I'm actually quite happy that I checked over here in the beginning after seeing that there was nothing in the end. Because again, what a lot of people do, this used to happen to a lot of my students, is they would say, well, there's nothing over here. How do we test the inductor? How do we test the chip? How do we test the diode? It's like, you don't want to test any of these things because you don't know if anything's getting to this. That may be a waste of time. So in sequence, remember, you have to do this, all the work that I'm doing, it needs to be done in a time frame where the customer is actually going to want to have it done. A lot of people say that component level repair is not economically viable, but I think the reason they say that is because they're missing these little strategies that kind of give you shortcuts to allow it to be. So I tried over here. There's nothing there. All right. Now we're going to jump up again. F7005. Technically, I should have checked over here, and then over there, and then over here after. But, who needs to listen to his own advice? I guess I was following it a little wrong. I should have zoomed out in the picture a little bit, admittedly. So we're going to check F7005 over here and see what I'm getting on the fuse. So let's see what the fuse has on it. And I'm guessing I'm probably going to have 18 volts there. Okay, 18 volts, so the fuse, all right, so let's continue. So now we know that our problem is going to be somewhere, let me just get this full schematic view on the screen. So our problem is somewhere between here and here. I'm going to guess that it has something to do with Q7010. Now, one thing to note over here is that a lot of the crap that you see over here doesn't actually exist. So like Q7020, Q7030, those, at least I have not actually seen that stuff on this board. So I just pretend that stuff is, this over here, I don't believe that this actually exists. So this transistor over here, Q7010. Now, how does this work? That's a great question. You could check out some of my older videos on how these transistors work to get an idea. So this is a P-channel MOSFET. And if you weren't aware, you can just Google that chip and it will tell you that it's a P-channel MOSFET. You can also tell if it's a P-channel MOSFET based on the direction that all the arrows are facing, but I realize with new people, sometimes it's difficult for them to memorize all of that. The way a P-channel MOSFET works is that if you have a voltage on the gate that is lower than the voltage on the source, then the source will be able to go through the drain. So this is kind of like a light switch, but instead of you flipping it physically, you're going to flip it when you send the right amount of voltage or take away the right amount of voltage from the gate. So let's check out how this works. This is going to send voltage from the source to the drain when the voltage in the gate is lower than the source. Now the source is going to have 18 volts coming to it from the fuse up there, which means that I'm going to be expecting, if this is going to work, to have a lower voltage in the gate than the source. Now how does this work? Well, you have R7010 and R7011 over here that are going to be taking that 18 volts from the gate, from the source, and putting it right on the gate, ensuring that the voltage on the gate and the source are identical, which ensures that this never opens. What does allow this to open is the fact that over here you have this diode that goes to ground, which is going to take some of the voltage that would have otherwise went to the gate and brings it to ground. This then turns this circuit into something like a voltage divider, where this on the bottom is, in some ways you can just kind of see it as a voltage divider, one resistor on the top, one resistor on the bottom, except here they're using a Zener diode just to keep things simple. This is kind of like a voltage divider. So this is going to do, if this diode is working, is it's going to ensure that the voltage in the gate is lower than the voltage on the source by sending some of the voltage that you're sending to this gate over here via R7010 to ground. And I'm pretty sure, if I were to guess, that we are not getting a voltage drop on the gate, which means that this transistor is never going to allow power to go through it. I'm pretty sure that that means that D7010 is either flicked off the board or broken, and I'm pretty certain that, like most Apple computers, that this diode on this machine will have HA on it, because the diode is laughing at you for buying the wrong product, which I don't think it should. I think that's kind of mean. I try not to laugh at people that buy Apple products. You know, it's not for me to judge, but it's really kind of fucked up that the machine is actually laughing at the person for buying the Apple product. That's fucked up. So we're going to take a look at this diode on the board and see if my theory is correct. I'm going to turn on the microscope and the microscope camera so that you can all see what's going on the board itself as I probe around, and let's see. So we go over here, and as you can see, this diode over here is laughing. I'm just going to do a 90-degree rotation so that you can see that it's laughing, because right now the HA diode is upside down. So I'm going to take my microscope camera, and just to make it easy for you to see on the screen, yep, it's laughing at you. It's laughing at you. Again, it's screwed up. You shouldn't laugh at your customers. It's not right to laugh at the customer, but they laugh at the customer. So what are we going to do? First thing I got to do is I have to just tighten up the microscope stand so that it's a little less shitty. That's one thing that we got to do. And the next thing that we have to do is do some measuring. So on the schematic over here, now the gate, I can measure the gate on pin 2 of C7012. So we're going to go check C7012, because on each side of C7012, we're going to have the source on pin 1, source on pin 1, gate on pin of the transistor is on pin 2. So we'll see if the voltages are different or the same. And I'm pretty certain that this is going to be a problem of the diode failing. And then if that is the case, then I will replace it, and I will bet that this will be a happy little MacBook once more. So let's see if we can make this a happy little MacBook. Kopaz is laughing. It's not right to laugh. So C7012 is going to be right here next to the transistor, and I'm going to load that up on my microscope camera over here. We're going to zoom in on that a little bit. I apologize for the smudges in the microscope camera. This thing is about 7 years old. It's been through hell, a couple of moves, and it just doesn't. I could probably replace it with another one. I just want. So we're going to check each side over here. Now, pin 1 is going to be the one pin on the bottom. You can see that from checking the board view. That's pin 1, and then pin 2 is going to be the gate. So let's see. Now, pin 1 is obviously going to be 18 volts. We expect that. Really? What? Okay, that's weird. Whoa. Okay, this is actually just a blown DC in fuse. No way. No way! No way! No way it's that easy! Wow! Okay. It was actually just a blown DC in fuse. Okay. Now we're going to... Are you fucking kidding me? How the hell did I get a board this easy? Okay, it wasn't the diode. Okay, there's no short to ground. There's no short to ground after the fuse. Are you kidding me? Did I seriously just get a DC in fuse? There's no way in hell. No way. No way. Okay, I'm just checking for a short along the path here. The PP342. No short here. No short here. What? That's bullshit. Oh, if Paul sees this, he's gonna fucking ram me, come in here and fucking scream. No way. No way. I got a DC infuse. You gotta be kidding me. Alright, let's see. PP342 has no short. I'm just checking some of the main power rails right now just to see if any of them have a short, to try and figure out why a fuse blew. Alright, so PP bus G3 hot, 329 ohms. That's kind of weird. That's kind of weird. No way. What made the fuse blow? I don't know. Again, the reason that I'm checking for shorts before I replace it is because I want to know what made the fuse blow. I'm not happy to simply replace the fuse without knowing why it blew. That being said, just my basic preliminary overview of it really does hammer home the fact that there's no reason for this fuse to have blown. Again, usually in this case, when this is the issue, it's that little HA diode that has died. That HA diode is a common piece to have broken, which is why I didn't really even bother checking the rest, because it's so common. It's not, you know, I'm not used to dealing with just the fuse dying. It's just, we don't usually get boards that are that simple. But my God, it was that simple. All right. I'm just gonna work this little fuse off of the board here. Yeah, maybe a bad power adapter. You know what? I'll check the current sensing resistors on the ISL6259 just to make sure that's all good after this part is done. Oh, man. Man, I can't tell Paul about this. I can't tell Paul I got a board with a bad DC infuse. That's just... Just got my Atten. Great station. I feel like the master of hot air. I really like the Atten. I remember when I started doing this, and like a decent hot air station was like $500 or $600. And now the hot air stations that were $500 to $600 when I got them are actually shittier than the Atten. Technology has come a long way. Where is Sharky? Ooh, I have Sharky outside somewhere. I have Sharky outside. I actually scared the piss out of Chris the other day. He was using the Zalmau or something, and then he turned, and I just had Sharky behind him on my hand, and then when Chris turned around, he almost shit himself because Sharky was staring him right in the face. I know, it's probably not the nicest thing to do, but I couldn't help myself. He was the only one that fell for it. It's weird because he's like the smartest person here, but he was the only one who fell for the Sharky. Okay, the fuse has been replaced. And again, we're just going to do some preliminary looks at the ISL6259 since this interfaces with the charger. Why the hell do you use so much flux? That's not a lot of flux. Why do you cheap out on the flux? The fuse, I've seen it blow by overclocking and bad adapter. That could be bad adapter. Check the good old current sensing circuit here. Yeah, this seems to be... Come on. Hold. All right. So I have high expectations that this is going to work. cameras here. Okay. So I've plugged it in the charger, and now it's taking 24 milliamps, no green light, not turning on. So we've got a bit of work to do. I really do part of me wishes it was that easy, but let's face it, life's never going to be that easy. So what we do here is, oh, okay, we're getting 18 volts there. Now we're going to check that our PP3V42 is present. PP3V42 is present. Now we're going to see if the SMC chip is turning on. Is the SMC turning on? It is, because I'm getting 12.58 volts, right? So I'm getting 12.58 volts on PP-Bus G3 Hot, which means that that is indeed turning on. Now we're just going to take a look at some of the one-wire circuit area. So remember, the SMC is turning on when it tells PP-Bus G, the chip that creates PP-Bus G3 Hot, to be 12.56 volts rather than 12.23, which is something I've covered in another video, how to tell when the SMC is working or not, that I'm not going to redo in this particular video. Now if we go over here and take a look at the adapter sense and all that, I'm just kind of curious to see if adapter sense is normal voltage or if it's 15 or 16 because the DC inboard died. Could be very possible that the DC inboard died and is sending 15 volts over to adapter sense. And that is not what's happening. Adapter sense is actually 3 volts, which is what it should be. It's just, so now we're going to check if, my charger's good. Aha. All right, so we just had to rub the charger a little bit there. And yeah, there we go. And just a little bit of zigzag over there. And the fan should be spinning shortly. Now, as you can see, it was taking 500 milliamps. Now it is not. Come on, you. Go, you. There we go. All right. Should probably just clean the charge port off a little bit. Let's see if we're getting CPU V-core here. Come on, give me 1.7 and 1.8 volts. There we go. So CPU V-core is present at the coil. And that's about that. It looks like this is a pretty straightforward fix. It was nothing but a fuse, which again, that just like, that never happens. That really, that just doesn't happen here. That's just crazy. I got a machine that was nothing but a fuse. Again, this usually doesn't happen, but it did happen here, and I'm quite happy that it happened here because I don't know. I'm never going to complain about getting an easy one. So that's about it for today. And as always, I hope you learned something. You probably didn't learn anything at all. I mean, even the biggest jackass when it comes to electronics knows the first thing that you check is a fuse. Can you believe that I got a machine that was just a fuse? Because this never happens. It's crazy. Absolutely crazy. Anyway. See y'all later.